Failure is the vanguard of success. The avenues of endeavour herald discovery. But this path has no end. Space is infinite. The questions are limitless. In a million years hence, we will still look up and ponder what is above and beyond.
This week, come on board mission STS-103 and join 7 astronauts as they track down the Hubble Space Telescope and attach it to their shuttle. The telescope desperately needs servicing, but only a risky maneuver and 3 successful spacewalks can ensure the completion of the mission objective. But first, this stark environment looks like Mars. In a way, it is. For planetary scientists at NASA's Ames Research Center anyway. Here, the scientists specialize in studying life in the universe. Instead of traveling to Mars, these experts are doing the next best thing. This diversified team of scientists has made their way into the remote, dry valleys of western Antarctica near the Ross Ice Shelf. They spend a couple of months each year probing the seemingly lifeless environment for clues to its makeup. Studying this barren and frozen ecosystem allows scientists to approach the investigation of Mars with a more educated eye. The Dry Valley region is a place where temperatures dip to minus 60 degrees Fahrenheit in the winter and are rarely above freezing in the summer. What startled researchers when they began their studies about 10 years ago was the discovery that microorganisms were living in the sandstone boulders along the valley wall. More recently, studies have shifted to beneath the rugged surface, which is actually a frozen lake. It's hardly what most of us would consider to be a lake, but nonetheless, after taking ice samples and melting a dive hole 13 feet down into the ice, scientists do find its liquid component. In 10 below weather, a diver dons scuba gear in preparation for the dive. Sample tubes are taken down in order to collect cores from the lake bottom. Once inside the ice manhole, light diminishes very quickly. The absence of swimming aquatic life is immediately noticed in the crystal clear water. At moderate depths, a thin carpet of algae can be seen covering the bottom. These primitive organisms, called stromatolites, in their fossilized state, may offer one of the best clues about life on another planet. The researchers seriously consider that these organisms are very similar to what they think might have existed on Mars, and even to what was thought might have existed on Earth in its earliest stages. Photographic evidence from the Viking spacecraft suggests that Mars had lakes at one time. Comparative studies in Antarctica tell us that life-sustaining water could have existed below frozen lakes on early Mars. Since Mars died an early death, it may hold good fossil evidence of first life on the mysterious red planet. Using the frozen lakes of Antarctica as a laboratory is an important first step in the future exploration of Mars. Knowing where life might have existed on the dead planet may lead us to the first evidence of other life there and at other places in our galaxy. In some countries, it's known as dramatically the death of the forests. All over the world, large wooded areas, once lush and green, are now sickly and grey. Seeking reasons for this dramatic decline, scientists have been studying the problem on Camel's Hump Mountain in Vermont, USA. This photograph was taken from Camel's Hump in 1963. Here's what this same area looked like 20 years later. To find out why, researchers began gathering samples of dying trees on various parts of the mountain. These samples, bagged and labelled in the field, will later be analysed in area laboratories. One theory why forests are dying is what's popularly referred to as acid rain. Pollutants caused by the burning of fossil fuels get into the atmosphere, are moved around our planet by air currents, and fall back to Earth in the rain and absorbed by the plants and trees. Based on the analysis of the samples collected on Camel's Hump, scientists are not convinced that acid rain is the sole cause of the problem, but they do think it's a factor. Specially equipped aircraft and satellites are also being used in the investigation to produce imagery of the study sites. Because the health of a plant or tree determines how it shows up in these images, they provide a very accurate way of discovering, mapping, and monitoring damaged areas. Scientists plan to use even more advanced airborne instruments to detect the first stages of forest decline before it becomes obvious. Small Vermont sawmills and the worldwide lumber industry in general could soon begin to feel the impact of what has become known as the death of the forest. But the problem goes beyond economic concerns, and scientists believe that we will have to find means of improving the atmospheric conditions. For that reason, these damage assessment efforts are vital as we look at the trees to save the forests. The Space Shuttle Discovery, poised for launch at the Kennedy Space Center, ready and waiting to catapult 7 astronauts into the stratosphere for NASA's mission STS-103. The mission marks the 3rd visit to the Hubble Space Telescope by space aviators and will include 4 spacewalks designed to install new equipment and replace old. The STS-103 mission will be commanded by veteran astronaut Kurt Brown, a colonel in the United States Air Force. Brown will be making his 6th voyage in space and the 3rd as commander. Pilot is Scott Kelly, a lieutenant commander with the US Navy. This will be his first flight into space. Interestingly, Kelly has a twin brother, Mark, who's also in the astronaut corps. During the mission, Kelly will be responsible for many orbiter systems during launch and landing and will back up Kurt Brown during the rendezvous and retrieval of the Hubble Space Telescope. 5 mission specialists are assigned to the flight. Mission Specialist 1 and Payload Commander is Stephen Smith. He's flying on the shuttle for the 3rd time and will team with John Grunsfeld on the 1st and 3rd extravehicular activities. Grunsfeld, Mission Specialist 3, also will be making his 3rd flight into space. European Space Agency astronaut Jean-Francois Clairvoy is Mission Specialist 2, serving as the flight engineer and primary robot arm operator. He's also making a 3rd flight on the shuttle. Mission Specialist Claude Nicollier from Switzerland is another representative of the European Space Agency. STS-103 will be his 4th mission into space, and he'll take part on the 2nd and 4th spacewalks. He'll be joined on those walks by Michael Foale, who's making his 5th journey into space. Though the 4 spacewalking astronauts began training for this mission more than a year before, the remaining 3 crew members were not named until 9 months before the launch, when the Hubble project called for this earlier than scheduled visit to replace the ailing gyroscopes. The training consisted of underwater activity in the Neutral Buoyancy Laboratory near the Johnson Space Center. and hands-on training in the Goddard Space Flight Center's 12,500 square foot clean room. As was the case with the previous servicing missions, the crew practiced every task it will have to perform during the 4 scheduled spacewalks. More than 150 special tools and crew aids had been developed for the servicing missions, and now the practical climax of all that preparation was at hand. As was the case with previous missions, relatives and friends were on hand to farewell the astronauts as they left crew headquarters en route to the launch pad. The time is the month of December 1999, and these men are the first shuttle crew ever to spend Christmas in orbit. Indeed, their schedule for Christmas Day called upon them to deploy the Hubble Space Telescope after 3 spacewalks had been completed, the efforts of the spacewalkers hopefully having restored the telescope to functional health. STS-103 would be the 27th flight of Discovery and the 96th mission in the history of the Space Shuttle program. A short while later, the launch pad cameras show the shuttle team reaching the orbiter access arm on the 190-foot level of the launch tower structure. It's difficult to imagine their emotions as they farewell the technical assistants with whom they'd become so close during the months of preparation for this launch. The final moments before takeoff are now at hand. On the flight deck, Commander Kurt Brown is helped into his seat. Despite his vast experience in spaceflight, or perhaps because of it, Brown is well aware of the onerous task ahead. He's responsible for the mission success and crew safety, as well as the ultimate authority for all mission decisions. He will be the prime crew member for the rendezvous and retrieval of the Hubble Space Telescope and the vehicle operation following the telescope's release back into orbit. On the middeck, Claude Nicollier clambers into position as he finds his seat on the starboard side of the vehicle. The Swiss national had previously visited the Hubble Space Telescope for its first servicing 6 years before. On that occasion, his role was that of the prime operator of the shuttle's robot arm. This time, Nicollier will serve as a backup to Jean-Francois Clairvoy during the rendezvous to reach the telescope, and as the operator of the robot arm during the first and third spacewalks. He'll also assist other crew members in discussing the science of the telescope during the flight. With Brown now securely in position beside him, pilot Scott Kelly is suited up by launch crew technicians. The bright sunlight shining through the orbiter windows is indicative that the launch should take place in virtually cloudless skies. Once the flight crew is secure, a planned 40-minute hold begins. In the Mission Control Center, NASA and the contractor project managers are formally polled by deputy support team members to verify that they are go for launch. Once that confirmation has been received from all sources, the Ground Launch Sequencer, or GLS, swings into action. The orbiter access arm connecting the access tower and the orbiter side hatch is retracted. If an emergency arises requiring flight crew activation, the arm can be extended either manually or by GLS computer control in approximately 30 seconds or less. The GLS auto sequence starts and the terminal countdown begins. Up until this time, the fuel cell oxygen and hydrogen supplies have been adding to the onboard tanks so that a full load at liftoff is assured. This filling operation is terminated at this time. The cap that fits over the ET nose cone to prevent ice buildup on the oxygen vents is raised off the nose cone and retracted. Transfer to internal power on Discovery is activated. Up to this point, power to the space vehicle has been shared between ground power supplies and the onboard fuel cells. The ground power is disconnected and the vehicle goes on internal power at this time. It will remain on internal power through the rest of the mission. Only one further command is needed from the ground. Go for main engine start at approximately T-9.7 seconds. All 3 engines are verified to be at 100% thrust. If one or more of the 3 didn't reach 100% thrust at this time, all engines would be shut down. On this occasion, the complex procedure operates perfectly. The Space Shuttle Discovery, carrying the flight crew for mission STS-103, has liftoff.
We have booster ignition and liftoff of the Space Shuttle Discovery on a mission to prepare the Hubble Space Telescope as we venture into the 21st century.
At T+19 seconds, Houston Center still controls the ascent. The standard roll maneuver is complete and Discovery is in a heads-down position on course for a 28.5-degree, 310 nautical mile orbit. The three main engines begin to throttle down to lessen the effects of the dense lower regions of the atmosphere on the orbiter. Discovery is already traveling at 700 miles per hour at an altitude of 3 miles and a little more than a mile downrange from the Kennedy Space Center. At 1 minute and 40 seconds into the flight, Discovery's system now weighs half of what it did at liftoff, having burned half its total weight in propellant. The next step in the launch is the burnout and separation of the orbiter's twin solid rocket boosters, or SRBs. The shuttle is now traveling in excess of 1,500 miles per hour. The SRB separation goes exactly as planned and, speeding at 3,500 miles per hour, Discovery and her 7 astronauts blast into space on the last human spaceflight of the 20th century. In a nice gesture, Commander Kurt Brown welcomes pilot Scott Kelly to space, Kelly making his first flight beyond Earth. 8.5 minutes after the launch, Discovery was in orbit as its crew members began to configure shuttle systems for the planned 8-day mission. One of their first tasks, opening the doors to the payload bay. One rendezvous burn of the reaction control system jets is planned to fine-tune Discovery's path to catch up to the Hubble telescope. That burn having been executed successfully, the astronauts catch up on some sleep before undertaking a busy schedule during the first full day in space for the crew of mission STS-103. Discovery was trailing the Hubble Space Telescope by about 3,700 nautical miles and closing at a rate of about 340 nautical miles with each hour and a half long orbit of the Earth. The 7 Discovery astronauts began a day of preparation, gearing up for the rendezvous and capture planned for the following day of the Hubble Space Telescope, or HST. Preparations also began for the 3 maintenance spacewalks that would follow later in the week. At about 1 p.m., European Space Agency astronaut Jean-Francois Clavois powered up Discovery's robotic arm to check its operation. Clavois surveyed Discovery's cargo bay using television cameras on the arm, checking the condition of the equipment planned for installation on the telescope and the cradle that will hold HST during the spacewalks. While Clavois operated the arm, payload commander Steve Smith and mission specialist John Grunsfeld powered up the payload bay HST support equipment. Later, Commander Kurt Brown and pilot Scott Kelly checked out the laptop computers, navigation aids and flight controls in Discovery's cockpit that will be used for the next day's scheduled encounter with HST. Meanwhile, on Discovery's middeck, Grunsfeld, along with European astronaut Claude Nicollier, began a check of the 4 spacesuits on board. Cabin pressure aboard Discovery was also lowered as part of the spacewalk preparations. This reduces the amount of time the spacewalkers must breathe oxygen as part of a standard protocol to purge nitrogen from the body prior to beginning a spacewalk. Amongst their final activities of the day, the crew fired Discovery's large orbital maneuvering system engines to slow the rate at which the shuttle was closing on HST. A second, smaller engine firing followed 1 hour later to further fine-tune the shuttle's approach toward Hubble. Mission control monitors report that Discovery is in excellent condition, orbiting Earth every 95 minutes and 27 seconds. The high point of Discovery's orbit is 363 statute miles, and the low point is 298 statute miles. By the 3rd day of the mission, Discovery was on track for its rendezvous with the Hubble Space Telescope, a day that would culminate in the planned capture of the 12.5-ton observatory. While the crew slept, the shuttle continued to close in on the Hubble Space Telescope at a rate of about 125 miles with each 90-minute-long orbit of the Earth. By the time the crew awoke, Discovery trailed the telescope by about 330 miles. The shuttle's thrusters were fired at 12:38 p.m. to slightly raise Discovery's orbit and slow the closing rate on Hubble. Another engine firing was conducted about 48 minutes later to further adjust the closing rate and aim Discovery to reach a point 8 nautical miles behind the telescope, the starting point for the final phase of the rendezvous. Controllers at Goddard Space Flight Center placed the Space Telescope in an attitude with its closed aperture pointed toward Earth. Kurt Brown guided Discovery through an approach from below and fly-around, and Jean-Francois Clavois powered up the robotic arm to lift it to a position just above its latches along the left edge of the shuttle cargo bay. As Discovery closed the final distance to Hubble, 4 small course correction engine firings fine-tuned the approach, and Clavois reached out with the shuttle's robotic arm to grip a grapple fixture on Hubble. The grapple was made 1 day, 23 hours and 44 minutes after Discovery's launch from the Kennedy Space Center in Florida. Clavois used the arm to rotate the Space Telescope and bring its base into the cargo bay. Within an hour, Hubble, gleaming silver in its mylar insulation, flanked by golden-colored solar arrays as tall as a 4-story building and with a maximum diameter of 14 feet, was firmly attached to the flight support system in Discovery's cargo bay. The system provides power from Discovery to the telescope and can rotate and tilt it to facilitate access to its various compartments by spacewalking astronauts. An initial, carefully choreographed survey using a camera at the end of the robotic arm was made by the shuttle crew. Whilst the astronauts enjoyed their scheduled sleep period, those camera surveys continued, allowing the scientific experts on Earth at the Mission Control Center to form their conclusions as to Hubble's condition. Join us next time as we watch the crew of Discovery carry out the main objective of STS-103 mission, the servicing of the Hubble Space Telescope that includes 3 spacewalks designed to install new equipment and replace old.